it's Sujit Wag. You are watching WikiNote channel. Welcome to the EEE question answer video tutorial series. Today in this video we are going to discuss about the question related with speed control of DC shunt motor by inserting resistance into the armature circuit. So this question was asked in the exam, that is May 2018, for 7 marks. So this is very important question, and this kind of questions will be asked in the exam. So we'll directly go with the numerical now. The input power supplied to a 500 volt. So DC shunt motor is 8776 watt. So first of all, I will write down the given things over here. So given things, as it is a DC shunt motor, so you have to write or mention DC shunt motor. Input power is given, which is PI, I will write, and 8776 watt. Next, voltage is also given, which is DC voltage, I will write it as a VDC, which is equal to 500 volt. So next is, it is desired to reduce the speed of a motor by 30% by inserting a resistance in the armature circuit. So you have to reduce the speed by the 30% from the initial speed. So I will call it as a new speed. It is denoted by N2 is equal to N1 minus 30%, that is 30 upon 100 times the initial speed, that is N1. See here, it is mentioned to reduce the speed of motor by 30% by inserting a resistance in the armature circuit. So the new speed will be less than 30% of the initial speed. So that's why I have taken N1 minus 30 upon 100 upon N1. Always write it in this manner. So if you solve this, you will get N2 is equal to 0.7 times the N1. This 0 and this 0 will get cancelled, and this will be 0.3. 1 minus 0.3 will be 0.7 times N1. Next, keeping the shunt field and armature current unchanged. That means your shunt field is not going to be changed. That means the flux flowing through that shunt field is always going to be equal. So phi2 will be remain same as that of phi1. And armature current, that is current flowing through the armature, that is IA1 to the IA2, is also going to be remain same. It is not going to be changed. The resistance of the field and the armature windings are 400 ohm and 0.25. Field winding, that means it is denoted by shunt, that is RSH, and which is 400 ohm mentioned, and the field winding, the armature winding is given whose resistance is 0.25 ohm. And what you have to calculate? The value of inserted resistance. I will denote it as R, and that you have to calculate, question mark. So first of all, we will draw the diagram of DC shunt motor and its circuit. So DC, you should know the basics of DC shunt motor. So this is shunt motor, so that means this field winding is in parallel to the armature winding. So I will draw the structure. This is symbolic representation of the motor. The voltage applied is VDC. The current which is flowing through this, the current which is flowing through this is ISH. The current flowing through the motor armature is called as armature current. This resistance is denoted as RSH. Okay. So now this is the total current I, this is ISH, and this is IA. So first of all, I will go for the solving this numerical. We'll start solving this numerical. How to solve this kind of numerical? As the power is mentioned PI 8776 watt. Voltage is mentioned DC voltage. You have to calculate I, and that I will be given as P upon V, because we know that power is equal to voltage into current. So simply I will write here this as a VDC and this as a input power. 8776 divided by VDC, that is 500 volt, and you get the value of current, and that comes to be 17.5 ampere. So this is the current flowing through the total current flowing through the motor. Next is, it is asked to find out the shunt field current, or they haven't asked, but we have to go for finding this current flowing through the shunt winding, so that we will get the current flowing through this armature. Shunt current, see here my dear friends, as this is a applied voltage VDC, same voltage is applied across these two terminals, and same voltage is present across these two terminals. There is no decrease in the voltages across the terminals. As this voltage is across, that means parallel to all these circuits. So ISH will be given as voltage VDC divided by RSH. Simple Ohm's law, that is I is equal to V upon R, and this will be 500 divided by, what is RSH? RSH is given or mentioned, and which is nothing but whose value is 400 ohm. So this will get cancelled, 0 0, and you will get the value as 1.25 ampere. So that is the current flowing through this shunt field winding. Now we'll go for calculating this current flowing through this armature. I will denote this current as IA1, that is the current flowing at speed, suppose N1, that is initial speed. So IA1 will be given as I minus ISH. Now you will ask from where this equation came. So this equation is nothing but apply KCL at this node. Current entering to the junction are treated as positive, while current leaving the junction are treated as negative, and the summation of the current at any junction is always equal to 0. That is the Kirchhoff's current law. And if you apply that law over here, this I is treated as positive, ISH leaving the junction treated as negative, minus IA1 is equal to 0, and just I have written IA1 is equal to I minus ISH. Hope you have understood from where I have taken this formula. So simply we know that value of I 17.55 minus 1.25, and it comes to be 16.3 ampere. So I got the current flowing through the armature. Next, I have to calculate the back EMF which is present at the armature. So for that I have to use EB1. So you should know the equivalent circuit of the DC motor. And how to know the equivalent circuit? See here the symbol equivalent circuit. I'm just drawing that part over here. This is your VDC, this is your field winding, and the circuit will be like this. You have some armature winding, you have the back EMF across the motor, and you also have the voltage due to the drops, or the V brush I will say. So here you are getting this resistance is called as armature, this is called as EB back EMF, and this is called as V brush, voltage across the brushes present over here, and this is your RSH. So I have to calculate, recently I have calculated about the current flowing through the armature, that is the current flowing through this part, and which is given as 16.3 ampere I1. So I can calculate here the value of EB. So apply Kirchhoff's voltage law across this circuit. Now this is closed circuit. As discussed, the voltage is applied across this to this terminal also. So if I use the equation, and that comes to be VDC, that is the voltage, minus the drop in potential IA1 multiplied by the armature resistance, minus the EB voltage minus voltage due to the V brushes, and is equal to 0. As I am considering IA1, so I will consider back EMF is equal to EB1. The voltage across the brushes is not mentioned in the numerical, so you have to neglect that part and you can write it as 0. So this equation is called as Kirchhoff's voltage law, which is applied for the equivalent circuit of DC motor. Now I have to calculate I know the VDC, I know IA1, I know RA. V brush is not given, so simply neglect that part, but if it is mentioned, you have to consider that part in the numerical. So I am explaining that part over here. So I will write here EB1 is equal to VDC minus, I simply take down this EB1 here to the right hand side. So IA1 into RA. V brush is not given, so simply consider it as a 0. So VDC, which is mentioned 500, minus IA1, which we have calculated recently, and which is 16.3 ampere, multiplied by resistance, and resistance is given as 0.25, that is armature resistance. Hope you are getting. I'm having some problem related with providing the point over here. So this value, if you perform the calculation on the calci, it comes to be 495.92 volt, and this is the back EMF EB1. Now see, very important, which is mentioned in the numerical, that the flux and the armature current is not going to be changed. So IA1 is equal to IA2, and flux is also equal to Phi2 is equal to Phi1. So my dear friends, here I would like to mention when it happened. See here, the speed has been reduced by 30% by inserting a resistance in the armature circuit. So you have to add a resistance in this armature circuit and keeping the shunt field and armature current unchanged. If the current flowing through shunt field and armature field is remaining same, then obviously the current flowing I1 is equal to I2. Similarly, ISH is equal to also going to remain ISH2, and flux is also going to be remain constant. So here I have the equation that is related with DC speed motor, but before that I will draw the diagram. For inserting the resistance. See here, now what we have done here, I will just modify this diagram by inserting the resistance. This will be RSH, this will be RA, then EB, then V brush Okay, this is my previous diagram. So we are just inserting one more resistance here, and I will denote that resistor as R. This is your RA, this is your back EMF, and this is your V brush drop, and this is RSH, field winding resistance. So VDC, this is the voltage applied across this terminal, current is I. Now I have inserted the resistance, this current will be IA2. Now current is going to be changed, and RSH is same as previous one, and as mentioned ISH and IA2 are, that is here the shunt field and armature current unchanged. So this is going to be remain as per the previous currents. So this is also ISH, but now there is addition of R. Now according to the speed equation of DC motor, we know that, or the back EMF equation of DC motor, we know that EB is equal to P phi NZ upon 60A. So if you look at this number, we know the value of pole, we know the value of whether it is a lap winding or whether it is a wave winding, then we can take down, or 60 we can consider it as a constant. Similarly, Z is the number of conductors over here. So we can also say that EB is directly proportional to the phi multiplied by N. So in this case, as I know the value of speeds, I know the value of EB, so flux is constant, or I will say here N is directly proportional to the back EMF speed of DC motor by flux, but in this case this flux is constant, so N is directly proportional to the back EMF EB. So I can write the equation like this: N1 by N2 is equal to EB1 upon EB2. So that will be my equation. The constant case value is going to be get cancelled. So N1, I know the value of N1, I don't know the value of N1, but I know the value of N2, and N1 I will write here N1 is equal to N2 is equal to 0.7 times N1, which we have studied earlier, and EB1 upon EB2. So EB1 we have found out 495.92 volt divided by EB2 is given. We have to find out EB2, but in this case here N1 will get cancelled, and you will get the value of EB2, and that is back EMF in the motor, and that comes around to be 347.1 volt. So I will just square bracket this down. So I got the EB2 value now. So can I calculate the value of this inserted resistance R? Yes. How to calculate that? Again apply the Kirchhoff's voltage law equation to this circuit. So voltage across this terminal will be VDC, and I will apply that Kirchhoff's voltage law, and I will get the equation. I will get the equation same as that of previous equation, but with addition of resistance. So I will write here VDC minus IA2 into RA, that is armature resistance, minus IA2 into resistance which we have added R, minus EB2, that is back EMF2, minus V brush, and V brush is not mentioned, so no need to take down that, and I will simply write it as 0. So I have to find out the value of this R. So simply here you can write, see my dear friends, here we can write VDC minus EB2 minus IA2 will be common here, in bracket R plus RA is equal to 0. So I will take down this term to the right side. VDC is given 500 minus EB2 is mentioned over here. We have calculated that value 347.1 volt minus IA2. IA2 is same as that of the IA1, because we have written in the numerical that current is not going to remain changed. So I will take down the value of IA2 here, that is 16.3. Just simply I will take down this value to the right hand side. So I will write here equal to 16.3, which we have got here, in bracket R plus RA. Now armature current value also I know. If I subtract this, I will get the value of 152.85 divided by 16.3 equal to R plus RA, and this value comes around to be 9.37. Now you know the value of RA. RA is given, which is 0.25 ohm. So if I perform the subtraction, I will get the value of inserted resistance R is equal to 9.1212 ohm. So this is the value to be, this is the value of resistance which is going to be inserted into the armature circuit in order to get the reduced speed. So if you look at the marking scheme, then it carries 7 marks. So this is very important part. you can consider this as a and this as a 1 mark question, then 1 mark for calculating the armature current, 1 mark for this, then 1 mark for this, and 2 marks for this. So total you will get 7 marks for this calculation. Hope you understood this video. Thank you.
Thanks for watching this video. Stay tuned for more such videos. Please like and share this video with your friends. Also refer my website wikinote.org. Follow us on our Facebook page WikiNote Foundation. The links for the same are provided in the description box below.